I want you to think about something. One of the main things that you're going to have to do over and over and over again is compare f to f prime, right? So if I have f, it's a function. I find f prime, we call that the what? Derivative, not a trick question, it's a derivative. And the derivative tells us what about f? Instantaneous rate of change, right? So the derivative is the rate of change, yes? Okay, so let's think about this. When f prime is positive, okay? When f prime is positive, what does that tell us about our function? When f prime is positive. Okay, so the slope at the given point is positive. So that tells us something about that point. What does it tell us about the function? What's happening with the function? It's increasing, right? If the f prime is positive, so we have that positive slope. So let's think about, you know, how Bruce always says this is your tangent line, right? So this is my tangent line. So on this function, my tangent line, my slope is positive, 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 right? So you see how my function is increasing? Then my slope gets negative, 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 and then my function is decreasing, right? So make sure that we can wrap our minds around all of that. Okay. She is not going to be here tomorrow. Well, maybe she will be. Okay, I will let her know that she needs to be here tomorrow. Okay. Because I'm ready for Thanksgiving. No. My hats get better as the week goes on, just so you know. And she will be happy. Okay, I will let her know. Yeah. Why? Okay. All right. So we are going to describe extrema on an interval. Okay, and this will be good because we won't finish all this today. You will hear it from me, and then you will hear it probably better from her tomorrow again. So just bear with me today, and she will repeat a lot of what I said. I mean, she's not going to start over, but we're not going to finish all this. Okay, so definition of extrema. They are extreme values, right? So this says, let f, that's our function, be defined on an interval, that's a capital I, containing c. So this is my, c means that is the x value. Okay, because we got to make sure that we understand what the heck we're talking about and what the heck we're looking at. So if f of c, so if c is the x value, f of c is the what? Y value. So f of c is the minimum, so we know about maximums and minimums, right? It's the minimum of f on I, so it's the minimum of the function on the interval if f of c is less than or equal to f of x. So f of c is a value, f of x is our function, right? What that is saying is that this y value, the y value is below all other values, below, let's say all, sorry, below the rest, I gotta say it the other way, rest of the function. And so that's why it's said that way. Whatever value we have, it's the lowest y value we have. And that's basically what it means, it's the lowest value. So just understanding what a minimum and maximum is on a graph isn't enough. We've got to make sure that we understand it functionally as well. And then the maximum is the flip side of that. If f of c is greater than or equal to all other values of f of x, then that is a maximum. We got our maximums and our minimums. Okay, we good with that? We have relative and we have absolute. We're going to talk about the relative extrema first. We will get to absolute. We'll kind of talk about it a little bit right now together, but we will focus on the relative. All right, so if there's an open interval containing c, okay, open interval containing c on which f of c is a maximum, then f of c is called a relative maximum of f. Or you can say that f has a relative maximum. All right, so let's look at our picture here. We'll go through these. This is just wordy stuff about maximums. So in the figure at the right, we're on this interval from -2 to 4. Okay? So f has an absolute maximum value. My absolute maximum, that is the overall maximum value, right? This is my overall maximum right here. What's the maximum value? That's the point. So which one of those is the value? 21. Good. So it has the maximum value of 21 at x equals 4. We have an absolute minimum value of what? Negative 15 at x equals negative 2. Okay? So we have a value and we have a location of the value. Those are two completely different things. All right, so then we have a relative maximum value. So here's my relative maximum value of what? Of 5 at x equals 0, and a relative minimum value of what? 1 at x equals 2. Okay. So a distinction that we need to make sure that we make is that the max or min value that is the y value. Right? Value of the function is always the y value. The max min location, max min location is not an ordered pair, it is the x value. Okay. Everybody okay with that? What questions you got? All right, so I want you to see that at the endpoints here, my function is not different, because this is f, this is not f prime. My function is not differentiable at the endpoint. That's why we talk about the open intervals so much. But at the relative maximum, what is the slope of the tangent line? 0, right? Because it's horizontal. Because we're increasing, then we're decreasing, right? So this is where your critical point of a relative maximum happens. Same with the relative minimum. The slope of that line is 0. Okay? So we're going to look at our critical points. So definition of a critical number and a critical point, possible relative max or min. Let f be defined at c if f prime of c equals 0. Okay? There's two different times it can happen. F prime of c equals 0, or if f is not differentiable, that means that f prime does not exist. Okay, so it's when it's 0 and when it does not exist. Okay, so if we have those times, then it's a critical number of f, and the point c, f of c, is a critical point. Okay, so c is a critical number. C is c, x, or y? X. So that x value is a critical number. The ordered pair is a critical point. Okay, we're okay with all that so far? A lot of information. All right, so we're going to come back and talk about these two. We're actually going to jump to I know, isn't it cool? I'm going to jump to an example, then we're going to come back and talk about all the little pieces. All right, so find this. It's on the next page. Okay, so what this says determine the intervals where f is increasing and decreasing. It says use the first derivative test, which we haven't talked about yet. We will. To determine the location of all relative extrema, use your results to sketch the graph. So I want to show you that we can do all of this stuff before we even talk about the new tests and things. Basically, it's just names for stuff we know how to do already. All right, don't want it to get confusing. So the first thing we're going to do is we're going to find our critical points. Find critical points. The way you find your critical points is we are looking for when f prime of x equals 0 or does not exist. Okay? If I want to find when f prime is 0 or does not exist, I probably need to find f prime. Would you agree with that? Okay, so we're going to find f prime. So f prime of x equals. So I'm going to take, is this derivative going to be fairly simple? Yes. So this just becomes 3x squared minus 6x minus 9. So I found f prime. I want to figure out when it's 0 or when it does not exist. Well, this is a parabola. Wouldn't you agree? So is there a place where it doesn't exist? No, I just need to find the zeros. So I'm going to set this equal to 0. So I'm going to factor. I'm going to factor out my GCF. It's going to give me x squared minus 2x minus 3 equals 0. Then I'm going to factor this, which should be fairly simple because a is 1, right? Get 3 times x minus 3 times x plus 1 equals 0. So my zeros are going to be -1 and 3. Okay, so I found my critical points. The next thing I want to do is I want to figure out when f prime is positive and negative. So this is a parabola, right? I mean, even if, no matter what it is, you don't have to necessarily be able to picture that. But it's when you have a zeros, your zeros are where it changes from positive to negative, right? So anytime you're trying to figure out if something is positive or negative on an interval, not necessarily, like if I was given a specific point, that's different, but on an interval, I'm going to use my sign charts. Okay, so now we're going to find when f prime is positive or negative. Okay. So that means I make my sign chart for f prime of x. On there goes my zeros, -1 and 3. And I can use my factored version here. This is positive, so it doesn't really affect anything. But if I substitute in a -2, this would be negative, this would be negative, that's positive overall. If I substitute in 0, that's going to give me negative positive, that's negative overall. If I substitute in 4, I get positive positive, that's positive overall. Okay? Everybody with me on the sign chart? No biggie? Okay, so I've done all that so that I can go talk about, so it asks me where it's increasing and decreasing. So I'm going to say is f increasing versus f decreasing. Now, we found stuff about f prime, but that tells us about f, right? When is f increasing? Or like just in general, when is f increasing? Okay. Yes. You reworded my question. You're not wrong. And don't be specific to this question, is what I guess what I'm trying to say. Not specific to this question, when would f be increasing? How would I know f is increasing? When f prime is positive. Okay, yeah, that's what I was trying to get at. But so you were right. But so f prime is positive from -∞ to -1. So I can say f is increasing on, we'll do this type, -∞ to -1. Anywhere else? Yes, from where? 3 to infinity? Okay. Yeah, you have to union it because you have two pieces there. And why is this? F prime is positive. Or you could say f prime is greater than 0. F prime is positive is fine too. That's what I was actually going to write, but it's the same thing, right? And then we can say f is decreasing. Do we close these parentheses? No, because this is always going to be on an open interval. Okay, good question. Decreasing on -1 to 3 because f prime is either less than 0 or I'm going to say is negative this way. So I did it two different ways. So you can, either way is fine. It means the same thing. I'll put this in parentheses. F prime less than 0. And here I can say f prime is positive. So you have to say it how you say it. You know, there's one of two ways you can do it. It's totally fine. Okay. So we did the increasing, decreasing. Then it says first derivative test, location of relative extrema. What is that? All right, remember we didn't talk about the first derivative test yet, but if I have these critical points, look back here. These critical points, what's the slope of the tangent line at those points? 0. And the slope of the tangent line comes from what? The derivative comes from f prime. So this is when f prime equals 0, when you have a maximum or a minimum. So do I know on here when f prime is 0? Yes, I found that, right? It's right here. So is that where I have relative maximums? Yes? Does that make sense? All right, so what we're looking for now is where are the relative extrema. So where, oops. Let me change colors here. Where are the relative extrema? Something very similar to this. All right, so I know I have relative extrema at -1 and at 3, but I got to determine if they are maximums or minimums. So I know they're here because of 0, right? This is a maximum because my f prime changed from what to what? Positive to negative. And that makes it a maximum. If it changes from negative to positive, that makes it a minimum. Or you can think of f increasing to decreasing. That makes that decreasing to increasing. Works both ways. Okay, so we know that it's a maximum or a minimum, so it makes it a critical point. We got to figure out which is which. No. So what's happening at -1? F has a relative, what? Max at x equals -1 because what? Because f prime changed from positive to negative. Okay. So f has a relative maximum. We talk about f prime. F prime tells us about f. F changed from positive to negative. That's what makes it a relative maximum. So what's the other one? Minimum. F has a relative minimum at x equals 3 because f prime changed from negative to positive. Okay. So we have rules that state all of this, but you don't necessarily have to memorize the rules because you already understand the concepts. You already understand what's happening on the graphs. To think about what's happening on the graph and what it would look like. So let's go back and talk about the increasing and decreasing, now that we've done one. Go back to here. Analyzing function behavior. So a function is increasing on an interval for any two numbers, x1 and x2. If x1 is less than x2, implies the x values, this x value is less than this x value, means this y value is less than this y value. Think about what that means. That means if I'm looking at this, and this x value here is less than this value, x value here, then this y value has to be less than this y value because it's increasing. Does that make sense to you? All right, so you don't have to spit out this type of stuff, but we have definitions that back everything up. It's decreasing if we look at these x values. Okay? This x value is less than this one, but the y value is greater. That makes it decreasing. Okay, that's just talking about increasing and decreasing algebraically. Tests for decreasing functions. So we talked about the fact that f prime of x is greater than 0, then it's increasing because we have a positive slope, right? F prime of x is less than 0, It's decreasing. That's what you already told me based on the slopes, right? So you know this, even if it sounds weird and new. Okay? Don't get all lost in the wordy word of it. So then the official first derivative test that we did it all based on what we knew how to do. Here's what these words say. Let C be a critical number of any function f that is continuous on an open interval containing C. If f is differentiable on the interval, except possibly at C, then f of C can be classified as follows. If f prime of x changes from positive to negative at the critical value, okay, we found the critical points. If it changes from positive to negative, it's a relative maximum. If it changes from negative to positive, it's a relative minimum. Okay? Positive to negative, think about what's happening. Positive to negative, it's like a hill. It's going to be a relative maximum. Negative to positive, it's like you're digging a hole. That's going to be a minimum. Okay? You okay with those? All right, so every time what you're going to find is the critical points and then do a sign chart. So let's look at G. In order to do all this, I have to find the derivative, right? So let's find the derivative here. So G prime of x is equal to 2/3 times x squared minus 4 times 2. Oh, what's x squared minus 4 to what power? Negative 1/3. Okay, we agree with all that? So that means this becomes my numerator. I'm going to have 2x times 2. That's going to be 4x over 3 times the cube root of x squared minus 4. Okay. Everybody good so far? Okay, so we are looking first for our critical points. Remember, that is when f prime is equal to 0 or does not exist. For f prime to be equal to 0, that comes from the numerator. Okay? If the denominator equals 0, the function doesn't equal 0, right? Oh, thank you, yes. It is true. That would make way more sense. G prime is equal to 0. So that comes from the numerator. So I set 4x equal to 0, so x would equal 0. That's one critical point. For G prime to be does not exist, that comes from the zeros of the denominator. Think about your rational functions, right? Means I have vertical asymptotes there. And so really, when I factor, so my denominator is going to be 3 times the cube root of x squared minus 4, if that equals 0. So I'm going to factor what's inside of there. 3 times the cube root of x plus 2 times x minus 2. And the fact that it's in a cube root and everything really doesn't matter. I just need to know when is this, if this is 0, that makes this whole thing 0, which makes the cube root 0, which makes everything 0. So I'm really just solving these two right here. And so here that x is equal to plus or minus 2. These are my critical points. I'm going to use those on my number line. We good? We've got critical points. Now we use them on our number line. Just like with rational functions, we used our zeros and we used our vertical asymptotes. That's what we have here, a 0 and a vertical asymptote. So this is for G prime. And on there I'm going to have -2, 0, and 2. Okay. And so I can start with -3. All right, so when I put -3, let's see, I don't really have one that to look at all this together. So if I put -3 in here, the top is negative, or this would be negative, right? And then negative 3 in here would be negative, negative. So it's negative overall. Just got to use all the pieces. Y'all with me on that? What I'm doing there? If I substitute in negative 1 in here gives me a negative. Negative 1 here gives me positive. Negative 1 here gives me negative. That's positive overall. I can substitute in a 1 here, that's positive. And then positive, negative, that's negative overall. 3 is going to be positive, positive, positive. Positive overall. Okay. What questions you got at this point? All right, so the first thing we're looking at is increasing and decreasing. So I can say that F is increasing. When is F increasing? In general, not specific, in general. When is F increasing? When F prime is positive. So I'm increasing here and here. F is increasing on the interval negative 2 to 0 and 2 to infinity because F prime is what? You just told me that. Positive. Okay. F is increasing when F prime is positive. So then I can say F is decreasing on negative infinity to negative 2 and 0 to 2 because F is what? F prime is negative. Yeah. It is decreasing because F prime is negative. Now, F prime might be increasing or decreasing. That's not what we're looking at. We're trying to talk about F being increasing and decreasing. Okay, we all good with that? Now we need maximums and minimums. All right. So we can say F has a relative max at, okay, what has to be true to get relative max? We change from what to what? Positive to negative, because we're changing from increasing to decreasing, right? So we change from positive to negative here, and that's it, right? So I have a relative max at x equals 0 because F prime changes from positive to negative. Right? Then I can say F has a relative, I can't spell or write, has a relative minimum at x equals negative 2 and x equals 2. That's I'm going to go with no. That's a question I honestly don't know the answer to, so I don't want to tell you one way or the other. I would just write it out. Because sometimes you have to be very specific. I'd be worried about that. You know what I mean? And x equals 2. F has a relative maximum. You can ask Miss Bruce that tomorrow. X equals 2, negative 2, and x equals 2 because F prime changes from what? Negative to positive. Okay. What questions you got? It did, because it says, when is it increasing and decreasing? So that's what I did in purple. And then it said the location of relative extrema, that's what I did in green. And the only way you get your answers from purple to green, purple and green, is to do the pink and the blue. Oh my gosh, I know. It's just terrible. You want to talk about pie? It's almost Thanksgiving. You have to talk about pie. All right, what questions we have? I did that for Christmas, so I don't know. If we have a door decorating class, I still have it. All right, let's look at the next one. I should. Oh, yeah? Okay. Short. The hand trick. Very good. Not yet. After Thanksgiving. No, we start before Christmas. All right, so what's the first thing we have to do here? Find the derivative. Find the derivative. It's quotient rule. Don't mess up quotient rule. You can do All right, so I would get f prime of x. So I take the derivative of the first times the second minus the first times the derivative of the second all over the denominator squared. Okay, do we agree with that? Okay. So I heard, do we have to simplify it or do we have to clean it up? So the answer is yes and no. You gotta think about what we have to do with this. We have to find our zeros of the numerator and the zeros of the denominator. Well, the denominator is factored and looks good. The numerator needs to be cleaned up. Okay? So we're gonna clean this up. I'm gonna distribute this, and so this is gonna give me 4x squared minus 2x squared all over 2x minus 1 squared. Y'all agree with that? Now tell me if I messed up. Okay, so then this gives me 2x squared minus 2x over 2x minus 1 squared. So then I'm going to factor the numerator, so I'm actually going to have that f prime of x is equal to 2x times x minus 1 over 2x minus 1 squared. It's very tempting to want to cancel something out, right? Is anything going to cancel out? No, it's not. Okay. Yeah, but we don't want to make up math. That's bad, real bad. But we're all good on this, right? So now that we've factored it all, we get our z. So we want to find when f prime x equals 0. That would be x equals, that comes from the numerator. I'm going to have a 0 and a 1, right? 0 and 1. I'm getting when f prime is equal to 0. And then when f prime does not exist, that's the zeros of the denominator, which is going to give me 1/2. Everybody agree with all that? Okay, so then we found that. Those are our critical points. What do we do with them? Math. We already did the math. We do the sign chart. I lost it. Sorry. Here we go. I'm going to do the sign chart, the engineering part, apparently. Okay. So for f prime, this is my sign chart. On here, I'm going to put 0, 1/2, and 1. And I need to be able to see my function. Scroll. Oh my gosh, it's terrible. Okay, so if I substitute in a negative number, negative 1, I'm going to get negative, negative. Denominator is going to be positive no matter what, right? So that's positive overall. If I substitute in a positive 1/4, that's going to give me positive, negative, then guess what? The denominator is positive no matter what. It's negative overall. Then I am going from 1/2 to 1. So I can use 3/4. That'll be positive, negative, positive. That is negative overall. And then positive, positive, positive. Positive overall. Okay. All right. Are we good? Okay. So I have all of this stuff. And I'm going to talk about increasing and decreasing, right? So I can say F is increasing. In general, when is this? When F prime is positive. It is increasing when it is positive. So it is positive here and here. So I go from increasing on negative infinity to 0, and then 1 to infinity. Do we agree with that? Okay, because why? F prime is positive. Then I can say F is decreasing on, okay, so F in general is decreasing when, can you do 0 to 1? Is it negative this whole time from 0 to 1? What happens at 1/2? The thing is, well, is it 0? What's happening there? It doesn't exist, right? It's an asymptote, so it doesn't even exist. So I can't, it's not positive, negative, it's not 0 either. So I have to split this up and say from 0 to 1/2, and then 1/2 to 1. Okay? Because, why? F prime is negative. We good so far? All right. So let's write out what's happening with critical points. So F has a relative maximum at, so we get our maximums in general when it goes from what to what? Positive to negative, right? Because it's like a hill. Positive to negative. So I get one right here. And that's it, right? Relative max at x equals 0. Because F prime changes from positive to negative. You gotta be careful and not to say just because it changes signs, right? Because remember how she said like do 50-50 shots from positive to negative. And then we can say F has a relative minimum at, okay, so in general, that's when it changes from negative to positive. This is negative to negative, nothing happens. Negative to positive, it's that right there, at x equals 1, because F prime changes from negative to positive. What questions do you have? Okay. So do you have to do all of this every time? Yes. Make sure you do it all before you start trying to guess at things and make assumptions about things, whatnot. All right. So on the next one, find the derivatives. Ugh. So rude for no reason. And they being bullies too, Kim. Okay. So we get 1 plus 2 what? Cosine x. All right, we're going to stop there today.